Thanks everyone for tuning in. My name is Dale Lutz. I'm one of the co-founders here at SAFE. Been here for more than 20 years, and I'm joined today by
Dave Campanis, who works in Pro Services.
And has been at SAFE, you just said, closing in on 10.
Coming in on 10 years in February, yep.
Right. So today we are going to be looking at raster processing, and more correctly, where am I getting the echo from somebody? But more correctly, we're going to be looking at raster, the things that can be done to get the maximum value out of raster and take the pain away from working with it. So while we're going to be doing a number of examples involving the FME product, the product that we sell, many of the concepts are valuable whether you use FME or not. So we're going to be teaching you a lot of things about raster and a lot of ways that you can wring information out of rasters independent of the tool that you're working with.
Yeah, it's actually kind of interesting because you know, here at SAFE, we use FME. We've developed it, and we do fairly simple problems with FME. But our customers have done some incredibly complex problems using our software that are far beyond what we can do. And it's kind of interesting to see what people have done and go on the web and go, "Wow, that's cool."
And that's exactly what we're going to be doing today, is digging into those customer stories. And I'll first thank all those customers that have shared their interesting work with us and with the world for us to poke through. So we have our limerick. Our friend Matthew had a nice quote from his professor that vector is corrector but raster is faster, which is, I don't know, is that true, Dave?
As a photogrammetrist, I'd have to say yes.
Yeah, but it is not. I think Matthew may be correct from the GIS side, but that is not a haiku. My wife is an English graduate, and she informed me that, in fact, that was a limerick that we had posted, not a haiku. So there we go. So we've already learned something, the difference between limericks and haikus.
Yes, yes, and this is a fun one to say when you're at a party somewhere and you've had a little bit too much to drink.
And I actually will not try to express that difference because all that I know is this one example is not a haiku.
Yes.
Okay, so let's go to the next slide. Oh yes, we have our cast of many characters. Not all of them are actually answering questions today, but I think we're joined by Dean and Dimitri. So Dean is the bearded guy that spent a long time in Bulgaria, but he speaks English and German just fine, so you can ask him raster questions in almost any language. And Mark Stokes, I know, is sitting there ready to chip in and has supplied the muffins this morning, so thank you, Mark.
Thank you.
And we got Dave, who's right here, and I'm going to ask you some of the tough questions, put you on the spot, because while you're talking, I'm going to be watching them come by, and out of nowhere, I'll ask you a question once in a while.
Oh, fun.
So I can tell you're excited about that. And Dimitri did not get his picture up here, and Stephanie's away on at a conference, so we lack the ability. We're just too helpless to put Dimitri's picture up, but he's also there. So bottom line is, ask us all questions. We'll be looking at that. We want to make this interactive, and we're going to stop once in a while to get going. Okay. So just to get a sense of our audience, on your control panels there's a thing where you can raise your hand or not, that little sort of hand thing, and please push it if you're brand new to FME. We just want to get a sense of how many people are aware of what we're up to. So just give that a push, and we'll see who is new, and then we'll try to get my statistician to make a guess as to how many. But for those that don't know, FME is a product that sits between a bunch of different formats and systems and allows you a convenient way to move data and apply operations to that data without writing any code, and to author those rules, those transformations very conveniently. Once you've authored them, you can run them on the desktop, you can batch them up, or you can even push them up to a server. And so we're going to be using FME as the tool to kind of inspect and rearrange and manipulate all the raster and vector data. And actually, it also lets you integrate data from a bunch of different places. So there we have all the hands raised. So thanks all of you that have tuned in for the first time. I'm confident even if you never use FME in your life, you're going to learn some interesting things about rasters that you will be able to impress your friends and bring up at parties. Like, for example, how the distance to the sun is a useful value to be aware of when you're processing certain kinds of raster.
Oh, yeah.
Are you going to learn that today, Dave?
I believe we will.
Okay. So yes, we're going to be looking at 5 different scenarios. We're going to dig in, and we're going to understand what they were doing and why it was valuable, and we'll look at how they solved that, and along the way pick up a few interesting tips. So that's our goal, is by the time you're done this, is to see, wow, raster can be used to solve an interesting variety of problems. It's a valuable data type to be aware of, and here's some approaches that can get that solution done more quickly. That's what we're hoping to accomplish.
Yeah, just point out that some of these solutions are not exclusively raster.
Yes.
So in our previous raster webinar, we dealt completely with rasters, and this is a real-world situation. In a real-world situation, you use raster processing, use vector processing, use a number of things. Now, the common core of these solutions is raster, but there will be other areas of FME involved as well.
Yes. So if folks were hoping we were going to go through our traditional 17 things you can do with raster, this is not going to happen today. If you are curious about things like just sort of introductory mosaicing, clipping, and kind of toy examples on all those things, we have the archives to our raster webinars, which will kind of get you to the basics. This is taking all that stuff and applying it to solve real problems.
Yeah, yeah. Rather than doing the same old webinar over and over again because it's online, and
yeah.
I think we nailed it last time. So,
right.
You know,
we knocked it out of the park.
We can't better it. So
yes.
We're doing something new.
Yes. Okay. So we're ready to get going. And Dave, this is where I hand it over to you to start talking us through these. This one is from our friends at WebSoft Developers, and they had blogged this, and take it away.
Okay, so I just switched to their blog here, and it's a little blog on how to deal with no data areas, or areas that are essentially null rasters. There are some operations that we do in FME that leave blank areas like reprojection and clipping, and there are a number of ways of handling this, and he discusses some of the ways he's handled it here. So I'm going to expand on that and give a quickie what to do with no data in Raster's lesson.
And that's an interesting thing because vector people are never used to this concept.
Yes, I mean database people have the concept of a null value in a table, but yeah, vectors, you're kind of there, you're not.
Right.
Whereas raster, you have to fill the grid.
Right.
So if you reproject an image, it comes off at an angle, and you get empty areas. So let's just take a quick look at that quickly and see what happens when we reproject an image in FME. So let's get my favorite image here. We'll drag that in.
So you're using the FME Data Inspector, which is a viewing tool. No, you're not. You're using Workbench.
We're going straight to Workbench.
I see.
So we're going to read in our GeoTIFF.
Is it a TIFF? Yeah, GeoTIFF.
Yep.
Yeah.
Image, and we're just going to take a quick look at it. There we go.
And here comes the, okay, there we go.
This is a section of Vancouver. And if we click on the image, we find it, it's in UTM 83, Zone 10.
Good.
So there's a funky little coordinate system used only in BC called BC Albers, and we're going to try reprojecting it into that and see what it looks like.
So that's the transformer you just put down there. You're choosing a coordinate system.
Yeah, if I can spell it correctly.
Oh, BC Albers, that's a good one.
There we go. So it's another common coordinate system used in British Columbia. So if we run that, we have now a reprojected image. And now FME, when it reprojects, it fills these null areas as best it can. So in this case, it looked at the image and go, well, I'm just going to make these black because I don't have anything to put here.
Okay.
There's nothing special about these the black areas.
It's just black.
Just pure black, yep. So if you have other pure black pixels in the middle of the image, there's really no difference there.
Okay.
So what we can do, though, is we'll move the reprojector out of the way a bit, and we'll add something called a no data setter.
Okay.
And now the concept of no data is that we take a color and we say, this is our null value. We're making an index to this color, and that's our null value. So in this case, now this is a raster band no data setter. So you set it by the band. So it actually only takes one value.
Okay.
So if we type 0 here, it's going to use 0 in each of the bands. So any pixel that has a 0 in each of the RG, the red, green, and blue bands, will be considered no data.
Okay.
So we're going to run that. And we see where we get. But the problem with no data is we've now absconded with one of the pixel values and said this is null.
So if something was black, so if somebody had a black car in the backyard, it's now no data in this image.
Exactly. So if we scoot into here, oops, now.
You have to try to find one.
I found it yesterday. Okay.
Somebody that had black originally.
Yeah, I thought it was around here. Okay. All right. Anywho, if you had a black original, it will turn to white. So
yes,
which is not something.
So you can't just go and slam randomly a pixel.
Exactly.
Value.
Yeah. In there, so you're going to get. I was really hoping I could show you, but They're sneaky little guys.
Yeah.
So what we can do instead of using no data is there's an alternative way.
Okay.
And we'll get rid of the no data setter. Goodbye. And there's a concept in rasters, at least image rasters, of an alpha value or a transparency. And this is added as an extra band on the image. And we can add a transparency band with the raster interpretation coercer.
Ooh,
now these are really long. You'll notice a lot of raster transformers have really long names. But if you sort of grab the key, the key part in the middle and just type that, you can usually avoid all the...
We've been accused of taking part in some illegal activities while we were naming these raster transformers before.
Yes. So here all I'm going to do is we're coming with our RGB image. I'm going to say, hey, make this an RGBA 32 image. And you'll see on the conversion options here, it says RGB to RGBA. We have a create opaque alpha band. So it's going to create a band in that same image.
Yes.
And it's just going to set it all to opaque. So it's saying not transparent at all. All the colors are rendered. But what happens when we do that is when we're running through the reprojector, now notice that we don't have those black areas anymore.
Yeah.
I should have pointed out that we get the same thing in the no data as well. The black areas are gone. Now the color is actually still black, but if we click on it, why is this not?
I think double click it maybe. Oh, that's their problem. You're not dropping a new pin. But anyway.
Yeah. Interesting. Oh, okay, there we got a pin.
Yeah.
So you see that the RGB values are 0, which is black.
Yes.
But in the data inspector, if you're transparent, because your alpha is 0,
yes,
it shows that as white.
Okay.
Right?
Because you're seeing through the back.
You're seeing through
but
the
if you
image.
click somewhere else successfully.
You click somewhere else, there we go. You'll notice alpha is 255,
yes,
and there's your standard color values. So now instead of sort of hijacking one of our colors to be a null data, we've actually added a whole new layer just to store the null data.
So alpha is better than no data.
Alpha is better than no data for imagery, for pictures, because it's easy. For an RGB image, it's easy to add another band, an alpha band.
Yes.
Where no data is best used is if you have a numeric raster, a single band raster, say like a DEM information.
Right.
Now DEM information is usually greater than 8 bits. It's usually 16-bit integer, and it's
floating point.
Floating point, yeah, and it's usually signed. So what you find is that the no data value there are usually set to the lowest negative value you can get. I believe for the USGS DEM, it's like negative 32,000 or so. It's basically a value that is never going to be seen in real life,
right?
And then you don't get the interference with your true values. So I mean, the thing to remember is imagery alpha, numeric, no data.
That's good.
Yeah, there we go.
Okay.
Quite a new phrase.
So anyway, your problem here was you were going to try to take these guys, mosaic them, and then reproject them.
Yeah. So we're just going to try. We've got the reprojector. Let's try a quickie mosaic. So let's go in here and we'll grab. So
that's one of the things you can do is grab a bunch of files. Is that what you're going to do?
Yeah. So we're going to grab a friend to this one. Let me just let this up. 80809 LM. 80809. There we go. So we want that one. And 607 LM. Control Shift. Now you can read multiple rasters at the same time in FME.
Yeah.
So we're just going to read those in together.
Okay. So 2 are coming in.
Now if we run this.
So now we're doing 2.
Now we're doing 2. You see we got the 2 images.
Yeah.
This is this faint little band in the middle. And that's really not actually there. That's just an artifact of the data inspector saying you've got 2 images here. So what we can do now is we'll throw in a mosaicer.
There's a 2 there as well, so that told us. Okay, so you're going to throw in a mosaicer after reprojecting.
After reprojecting. And we'll run that.
So it's going to lay those things into 1.
Yeah.
And honor the alphas. Whoa.
Whoa.
Pac-Man.
Oh, that's because I forgot to set something. It's right here in my script, and I still forgot to set it. Okay. By default, the raster mosaicer is looking for no data values because of the mosaicing. But there's an option in here that says composite using the alpha band. When we turn that on, we say yes, because it's imagery. We want to do that. So now let's try that again.
There was some tension there, Dave.
A little bit.
Hey! Oh, that's a lot better. Can you flip back to view 6 just to show that in slow motion?
Okay, so we go from that where the null data is actually overwriting the previous to here. And now if we zoom, actually we can zoom in both at the same time. So I'm guessing that we won't we should not see our seam line at all.
Yeah, yeah, it won't.
And we're pretty good. I mean, there's no, we're completely seamless.
It's sewed it together.
Now, in practice, I mean, this just shows you what you can do with the alpha and the no data.
Yeah.
In practice, if your memory usage will allow it, generally I suggest mosaicing before reprojecting, because then it's just you avoid the problem of these internal seams together, and then you can actually skip the alpha step.
So why don't you show us what that would look like?
Okay. So let's get rid of you, and use our little pink triangle, put you in.
So you'd mosaic.
And then reproject.
And we'd have to redo our alpha stuff. Okay. You got alpha troubles.
Yeah, we got alpha troubles. Okay, turn off the alpha. There we go.
There is no alpha because you didn't have one.
Yeah.
And so now we'll have the black around the edge of the, yes.
Yeah.
And now we could go put it back, but at least we don't have the seam.
You don't, yeah, that's a completely seamless image.
Yeah.
Yeah, the raster transformers tend to be a little, it's not so much touchy, is that the design philosophy is raster processing takes a lot longer than vector.
Yeah.
So if you're going to make a mistake, we try to tell you before you've blown a couple hours on doing a process that then doesn't.
Right, so in this case, the parameter there said use alpha. Stuff was coming in without alpha. We get mad and say, hey, what do you want? What are you doing, buddy?
Shut her down. You're not sending me the right data. Are you sure you want to do this?
Yeah. Okay.
Okay. Now we have another interesting issue, is that let's get rid of this mosaicer, and we'll look at this area.
Okay, so you're taking one reprojecting it.
Yeah, reprojecting.
Whoa.
Now, if we look at this, we've got our null area here, but there's also this. This is previous. This is basically where they filled the grid, but they don't have enough information, and we could set that to no data. But if we look at it, it almost looks like there's different values in here. And if we zoom in, we'll notice it's not a pure white. It's kind of a mottled color. So we can't just use the no data to sort of erase that. We could do some sort of fancy raster processing, but then, I mean, we have the problem that we might grab some pixels that are actually true data. So there's a little story back in ancient times of Alexander and the Gordian knot, where I believe he inverted Persia, and to make him king, they said, well, you have to untangle this really complicated knot. And Alexander just took out a sword and cut it in half.
That's kind of like that Indiana Jones scene where he just shoots the guy.
Exactly.
Same sort of thing.
So we're going to shoot the guy.
Okay.
And the way to shoot the guy, actually, let's put in our interpretation courser back here, because I want the alpha.
So you're going to throw, just tell it, hey, make an alpha for me.
Yeah, because we're gonna want the alpha because we still want the nice edges. And I'm going to use a boundary to clip.
Oh, because you've got a vector boundary.
I have a vector boundary of this data. So we're going to drop in the vector boundary of the data. It's a Gmail file, and this is all this data is from the City of Vancouver's open data. So we're going to throw that GML in there. So we've got our grid data here, and let's just throw an inspector on that and see what this all looks like.
So we're going to see the grid on top of the image here.
Yeah. Maybe.
Oh. We got reprojection troubles, Dave.
We got reprojection troubles.
Well, they're in different coordinate systems, I bet.
Yeah. Okay. So what we're going to do then is we'll turn this off, and then we'll look at our grid.
So we just disabled that one. Yeah, we can't be over there.
So there's our grid. There's our boundary anyway. So now we've done that, we're going to put in a clipper.
Before reprojecting, I'm guessing.
Before reprojecting, yes. And so that's the clipper. This is the clippy. And we want the inside data.
Okay.
And let's re-enable that and run this.
There we go.
There we go. So we have just the data we're interested in. It fills the grid, no data outside, and all that extra white stuff is gone.
Right.
And I should explain the reason that some of that no data value, the original no data value, might have gotten that mottled color, is that if it's saved to a lossy, compressed format. Now, lossy in the terms of a raster doesn't mean you lose pixels. What it means is you lose detail. And how you lose detail is it changes the color of the pixels. So that what used to be probably a perfectly white area, once it's gone either through JPEG compression or UCW compression or any compression that's lossy, might result in that mottled artifact.
Yes.
So that's a good place where it's, like I said, bring in your sword, bring in your vector sword and cut that knot and just clean up that data. And that's actually part of what Troy used on his in his process as well, as he used vector at the end to sort of reclip new tiles.
Right. I mean, the other thing would be, if you are in the business of compressing, put the alpha channel on ahead of time so that you don't get in this situation.
Well, some formats support alpha, some don't.
Yes.
If you're going to ECW and you do have null areas, I really advise using an alpha channel, because it does store alpha channel.
Yeah.
If you're writing to JPEG, unfortunately JPEG does not store alpha, so you're out of luck. Yeah, you're out of luck.
Send the boundary along.
Yeah. If your format does support alpha, definitely use it. I think GeoTIFF supports alpha. Ping supports alpha.
So really, JPEG is the main outlier there.
Yeah. Unfortunately,
do you know about JPEG 2000?
J2K, I'm not sure. I think it might support alpha. It's pretty broad, and it's for different channels.
Dean will tell us later. Yep. Okay.
So that's the end of that demo. So let's get back to our slides. And okay.
There we go. So yeah, so that was what our WebSoft friends did, and it's just, when there's tiles, it's a common thing. Let's mosaic them, let's reproject them. You've got to keep your wits about you about the order that you do things, and that no data doesn't turn your stuff into a little Pac-Man.
Okay, well,
you saw the solution. One of the things I love about doing an FME user conference every few years is it gives us a whole new set of pictures of our staff in doctor's outfits. And so Dave was so excited that we hauled this out. So Dr. Dave, what's your advice on this one?
Well, generally, if you're going to apply your no data and on your alpha before any reprojection or clips, because FME will look, rather than having to fix it up afterwards and go, geez, I've got to put alpha, or I've got to put, and then working, do it ahead of time, because you can have alpha on an image with no empty areas, and we still have that channel, or no data, and we still have that channel, and as soon as we apply any sort of information, any sort of transformation that results in null pixels, those null pixels will be converted to the appropriate representation, either alpha or no data.
Right. And again, another of Dr. Dave's little quip was that numeric for no data, the two N's going together. That'll be on the test after.
Yeah.
Numeric for no data and
alpha for imagery.
Alpha for imagery. Okay. So that's the things to be aware of. Okay, now we're going to go to, this was in Holland somewhere, right? Or
yes, and it's one of our power users in Holland, and I hope I pronounce his name right, Itai. He has a solution where he wanted to grab all of this new Dutch raster DEM information, but he didn't want to sit there and download all the tiles. So he found that they had a GeoRSS file that listed all of the downloads, and he could just use FME to read that and download everything in bulk while he was off at the pub having a good time.
And I see that Ite is even listening in. So
good.
Thanks, Ite.
I really hope I got the pronunciation right.
You can correct us wherever you need to. Thanks for joining us. And I see that he loves XML as well.
Yes.
So that makes him a favorite of the other co-founder of SAFE, Don Murray.
Yeah.
So GeoRSS is a form of XML, but we can just read it directly without even caring that it's XML, I suspect.
Exactly. So the problem we're solving here is utilizing a remote raster data set. So all your rasters are stored off on some other system, and you want to grab the ones you need.
Right. So they're available via URLs.
Yep.
They're out somewhere else. We want to be smart about using our bandwidth because they're big and chunky, and we're going to have some fun pulling down what we're interested in.
Yeah. So this is the solution that I used, and I went a little bit different. I decided, well, we don't want to grab all the rasters. What we just want to grab are some of the rasters.
Right. So I think Ite's original one was to grab them all.
Yeah.
And you're going to go ahead and just grab a few. So
I'm just going to grab a few. So let me just kick over here.
Story 2. And we're going to share these workspaces later on with everybody. So if you want to look at them, you can. Okay. Yes, I remember this.
Yeah. So in this, we're doing a little bit different. So I've asked the user for a bounding box. So if you go into the published parameters, I asked him for his minimum X and Y, and also a coordinate system for his bounding box. And
we're going to take a peek at that?
We're going to take a peek at that. So this is the tile metadata here. It comes through as a GeoRSS format. I'm going to just look at it quickly.
So we're hitting some site out in Holland?
Yep, we're saying hello to Holland.
And we got, there's
1,373 tiles, and if we look at the information on the tile, we have, where is it? We have the ID, which is the name of the TIFF file.
Yeah.
We also have the, let's move this over.
There's a full URL there.
Yeah. So, yeah, there's the location. So if we click on this, we can actually download that zipped TIFF file.
Right.
And
actually, do you want to? We'll do that in a minute. But what else you got here?
We have the ID of that particular tile. We have some other information. But you know what we don't have, which I would really like, because these are tiles, right? And so you'd expect that the boundary of this, of each
entry here
would be the tile boundary, and that would make my life so much easier. So I could say, just give me the tiles within this area.
But the boundaries are all identical
for the entire tile set.
That's sad.
Yeah.
So that's one of our problems. But Dave, I really want to look at one of these things. So how can we copy they're zipped up as well. So what if you, let's see.
We should be able to grab it here.
You're going to paste it in there. So
I'm just going to ask this if we want to download the zip.
Yeah, okay, let's not bother with that. Okay. But what if you go into the FME Data Inspector and just say open?
Okay.
So we go here, open data set, paste that in, and we get, what is this going to be, GeoTIFF again?
Probably.
So wait a minute, we're going to pull it, even though it's zipped and at a URL, we're just going to hit OK and hope for the best.
Yeah, this may take a while.
So we're pulling it down all the way from Holland.
Yeah.
And then we're going to unzip it locally, and then, oh, there it is.
There it is. So it's a DEM data. So there we go.
And it's all low values because we're in Holland.
Yes. Yes, I think they have to go for a pretty high precision on their data just because there's not a lot of height to work with.
A lot of terrain there.
So, and that reminds me, this one takes a while to run, so I'm going to start it running now.
We also wanted to take a look at that RSS feed just for fun, didn't we?
Yeah, we took a look at the RSS feed.
No, but I mean the actual XML because Don might be watching.
Oh, okay. Hang on, we can do that.
So if you just get it off of here, if you open that up probably and edit the data set, there it is. There we go, copy that thing. And if you go into your fine web browser, you can look and see what's in there. Yeah.
Whoa.
Oh, I guess Internet Explorer.
Oh, no, there you go. So yeah, that's the GeoRSS file. It's XML format, which is. But luckily we have the GeoRSS reader, so you don't actually have to worry about any XML in here.
So anyway, that's our XML fix for today.
Okay. So what I've done is, like I said, we don't have a true index, so I can't really do a search on index from that GeoRSS feed. So I found on that same website, and it took a while because it's all in Dutch, a tile index WFS service. Now this was originally going to be a shapefile. I earlier downloaded a shapefile so I could show you how you get the shapefile over the URL, but for the life of me, I couldn't find it on the website again. So I found a WFS instead, and we're going to work with it. And that's the beauty of FME is you're not tied to any format.
Right. So if they take away the shapefile on you, you can switch to their web page.
Exactly. You can find something to make it work. Oops, you're too soon. Okay. So this is we're bringing in the tile index WFS service, and if we just look at that.
So you're just going to inspect that in its own view here. Whoops.
Oh, sorry, with WFS I have to tell what layers I want. There we go.
Even if there's only one.
Yeah.
All right.
Okay.
So now we're going to Holland again.
Okay.
Oh.
See, now we have our tiler boundaries. It's like, woohoo, we have boundaries. And if we look at the boundaries they have in their, where is it? Here we go. The Bladner. Okay, I'm sure that means something, but this has a tile ID.
Yes.
This tile ID, if we switch back to this view, we notice that is very similar, although not the same, as the actual name of the zip file that we want to download.
Yes.
So the first thing we have to do is make a common link between these two. So I use a string searcher here to take the ID from the GeoRSS. I use a regular expression to extract just that tile number. Now the regular expression looks really cryptic, and it is really cryptic, and quite frankly, whenever I do these things, the first thing I do is I head off to this site here, and this allows you to test your regular expressions and play around with them. It's like a good sandbox to test them, and it's unless you're a genius with regular expressions, it's pretty much absolutely necessary to do this. So anyway, I isolated that ID number from there. I renamed it to the Bladner, so both these things have a Bladner call with the same value in them. Use a feature merger. Now what I'm doing here is I'm taking the geometry from the WFS feed, and I'm requesting the actual location, all the information off of the GeoRSS because it contains the tile information.
And so basically, because you've got a spatial filter going on the WFS feed, that's going to mean, and from this run you can see it only pulled only two of the tiles matched your requirements. And even though there were 1,300 options coming in from the GeoRSS of a catalog of all the tiles, only 2 of them are going to match, and that's what's going to come up the merged, and that's what's done our weeding down.
Yeah. So you see, yeah, I've linked here to the min-max on the WFS feed is also linked through to this min-max. So it's actually applying that filter on the WFS read.
Yes.
Okay, so we've merged the tile ID, or we've merged the geometry with its location. Next thing, we're going to use a Raster Reader, and the Raster Reader is just going to look at that link URI, which has a full link for that TIFF file, and it's going to read it as a GeoTIFF.
And pull it down. In fact, and the wonder of it is, again, the fact that it's a zip file and it's at a URL, we're just going to deal with all of that for you.
Exactly. So we download these tiles from the URL, we throw them into Raster Mosaic here because we want a single image out of them. Now, our spatial filter, if you will, only grabs full tiles that overlap our boundary.
Yes.
So there's a good chance that this DM may be larger still than the area we're interested in.
Yes.
So the next thing we do is we reproject the mosaic to the envelope coordinate system. So you've asked for an LL84 box. We're going to give you an LL84 box regardless of what this raster is actually stored in, which I think is some Dutch coordinate system. But the other thing we do is we create a clipper from the search area. So we're bringing the same parameters we used over in the WFS reader in to create a 2D box.
Right.
A simple vector polygon, and we're going to clip that mosaic to the search area.
Right. So if you open up the Reprojector, Dave, that's where, so basically whatever the images were, which you're just saying source is read from feature, then you're going to turn them into what the person had said they wanted to work in.
Exactly. So if you asked for a UTM coordinate system to work in, you'll get
or a special Dutch one.
Yeah. Or in this case you asked for LL84, you're going to get LL84.
So that's what ran there while we were chatting.
Yeah. And that should be, if I scoot over here.
Which one is it?
This one. So here we have our mosaic. It's a DEM information.
Look at how tall that was. 22 meters. That's a mountain in Holland.
Yes. We might have hit the top of a building there. And if you look at the coordinate system, it's LL84.
Right.
It's properly clipped, and you have your information. And it didn't really take that long, even though none of the data we're dealing with here is on my local system. It's all over in Holland.
Right.
So you could publish this up to FME server, put a Google mapping engine front end on it, and have people just clip and download from somebody else's service completely, as long as there's full permissions.
So it's a way of leveraging a lot of that government open data, so you can get it when you need it, basically.
Exactly. And you can customize the delivery of it to suit your user's needs.
Yeah. So in this case, you just popped it up into our viewer, but normally you'd be saving on this right-hand side. You'd be saving to GeoTIFF or something.
GeoTIFF or any of the numeric formats.
Right. Esri grid. There's a favorite.
That shows how old we are. We're remembering the ones that were cool 20 years ago. CDED, yes, and I think USGS DEM or So
STTS. I don't know if we can write the STTS DEM. Probably we shouldn't. As a matter of public policy, we just shouldn't do that. But if we did, that would be another one. Okay.
But I think everybody just pretty much writes her as GeoTIFF because GeoTIFF can handle the real 32 data, real 64 data. So that's the end of that demo. So let's click back to our slides. And have I lost my place?
There we go. No, we're whoa. Okay. So there we go. Yeah, you walked through all this.
Okay. So here we have Dr. Dave's advice. Pretty much we're just federating the GeoRSS and WFS in place of shape data to get the required tiles. I showed you how to raster download and mosaic. And showed you at FME we can read from both URLs and zips, and we can actually read from a URL that contains a zip and get to the underlying data all in the reader without you having to do anything at all.
Right. So that's what Itay was working with, and so thanks for writing that up for us to talk about today, Itay.
Yeah.
So we're going to just stop there for a moment and look to see if there's any interesting questions or answers. Some folks are asking about geodatabase stuff and the differences between mosaic data sets and catalog data sets. Do you work with this stuff, Dave?
A little bit, and so I'm going to run screaming from the room at this question and refer to one of our more geodatabase savvy QA people.
Right. So anyway, we do support all those concepts, and neither Dave nor I are experts on them, but behind the scenes, I know that Mark and Dean and others that are answering are working on that sort of stuff. But yes, we haven't actually going to talk about rasters in databases today actually at all. But in general, you can support we can put rasters in databases.
Yes, and actually we can even put rasters in databases that don't support rasters.
Yes.
And there's a little, this is actually going to come up in a different context a little bit later on, but we have the Raster Extractor, which will essentially serialize your raster into a blob attribute, which
yes.
you can then place on into your database as a blob. And so you can store that. And if you have a spatial database that doesn't support rasters, we can actually replace the geometry of that raster with its bounding box and keep the raster information as a blob.
Yep.
So if you want to do searches like we did before, and you say, well, give me all the tiles within a certain area, you can do the search, get the vector tiles back,
yeah.
and using a similar workspace, extract that raster from the blob, replace it with
yes.
replace it with the vector with it, and then boom, you've got your raster tiles.
So, for example, Don might do this with a NoSQL database.
Exactly.
Which you could use a web-based NoSQL one to do this kind of thing. On the other hand, ones that actually do support it, PostGIS supports full raster. We can read and write out of there. Oracle does raster.
Yeah.
SQL Server does not, so you'd use the technique you just said.
Actually, yeah, that's the technique I use mostly on SQL Server.
Yes.
But,
yes.
I mean, many of the databases are coming around to raster support now, so
yeah.
the workaround isn't quite as necessary as it used to be.
So someone's asked if we can do pan-chromatic or pan-sharpening, and if we did, what transformers would you use?
A word on the street is that our strange things to do with FME guru, Dimitri, has done some pan
yes.
sharpening using the Raster Extractor and Evaluator, which we will showing later. We're actually going to have an example of pan sharpening, but done by somebody else.
Right. So you can do it sort of. We are working to make that a cleaner thing, but in an example coming up, we'll show how we did it by calling out to ERDOS.
Exactly.
So is that cutting the Gordian knot again?
Well, we'll get into that later, but it's just making FME do what it does best and using other tools to do what they do best.
Yeah. But anyway, we'll see if Dimitri can do it. Some people are asking about resizing images to resample them. Can that sort of thing be done?
Yeah, you can. We have a raster resampler that you can use to resample your imagery.
Yeah.
You can upsample or downsample, and when you're downsampling, and actually if you're doing any manipulation that involves pixels becoming what they were not, i.e. merging two pixels or moving pixels a little bit, we have several different ways of doing that. We have like the nearest neighbor algorithm, which is used mostly with numeric. We have bilinear and bicubic. For imagery, bicubic is kind of the gold standard.
Yeah.
Where it just retains the detail of your image as much as possible.
Yeah.
So when you're resampling down, the bicubic convolution will make all the detail recognizable. Whereas if you just did a straight, throw at every
yes.
fourth pixel, what happens is after a while things just look speckly.
So that's the key thing there, and it's not on any slide. Dr. Dave's tip would be when you're resampling, choose the technique correctly.
Yeah, the bicubic technique, and that comes from my work in orthophotos where we always had to use bicubic.
We had somebody else ask if we can clip to things that aren't squares.
Yes, we can. We can clip to any polygon. However, the resulting raster must be rectangular. So you will get those null areas.
So that's where the no data or alpha.
Say no data or your alpha. Or if you're just happy with black, you'll get black.
Right. And I think with that, maybe we'll get back to the rest of the story here.
Okay, our next customer story, Dale gets to talk about.
Yes. So this is our friends in Spain that really they're doing amazing things with FME. You can read up on what they did with more detail, and boy, that looks like a nice place to visit, doesn't it, Dave?
Yep.
So we should go and see them. But what they were really doing was trying to leverage a satellite sensor that was in the air returning data, but there wasn't software around yet, or at least they didn't have access to software that could do some of the analysis from the raw data coming back from that satellite. And so I'm not going to get into the details of all this stuff, but just to say that they were able to use FME and apply the transformations necessary to that raw data by knowing such things as how far away the sun is from the Earth and scary things like that, and doing these calculations. So really they're setting up a bunch of parameters where they can fill in metadata about the scene that they're in. They can figure out how far away the Earth was from the sun at that time using something in FME we call the expression evaluator with interesting constants, and well, at least pi is in there. That's one I can understand.
Yeah, lots of trig.
lots of trig, figure all this stuff out that you do once for the whole scene, and then once you're done it for the scene, you can go ahead and actually apply a function to every value in the raster that makes use of those pre-calculated values, and then does some other math to end up calculating these indices down at the bottom left. So this is all about trying to, in the end, figure out, okay, wait a minute, how are the grapes doing?
Yep.
And so by doing all this scary math, you end up getting these indices, and that is the information and the value that you want, and then you get this fine kind of an image here.
Yeah. So that was an example of sort of how to do math on a single image.
Yes.
You've taken for each pixel and some constants, you're calculating a new pixel value.
Yes.
Based on those constants.
You're deriving some kind of new measure which then is meaningful to you for what you need done.
Yeah. So I'm going to follow that up with another example of doing raster arithmetic. This is a slightly different customer story in that this is, I believe, our Department of National Defense wanted to look at the areas around their runways and cut down any trees that might smack into their airplanes.
That sounds like a good thing to do.
Yes, yes. So what they did is they had a LiDAR data set, and they were going to, so we're starting with LiDAR, we're going to use some raster processing, and in the end we're going to get vector data out, so it's quite the combination here. So let's get to the solution.
So LiDAR is coming into this thing.
LiDAR is coming in. There we go. So LiDAR. Sorry?
You're going to run this thing, or?
Am I going to run this thing? Yeah, let's run this now.
Okay.
It takes a while to run. We're going to read in the LiDAR data, and I would pull it up, but it takes a while to read the stuff, so it's a little...
Sure, it's a huge amount of LiDAR, actually.
Yeah, yeah. So what we do is we bring in these point clouds. We are going to combine these point clouds all into a single point cloud. So like kind of like it's essentially the same as mosaicing a raster. We're mosaicing the point cloud. So instead of being separate features, they're all treated as a single point cloud. We have defined here an area of interest, defined a little differently this time. This one's actually defined as a series of coordinates rather than a coordinate in each parameter. But we are going to create an area of interest, a polygon, and clip like we did with the rasters. Now here's an interesting thing about clipping with rasters and clipping with the LiDAR, in that FME in a way does the LiDAR processing in reverse. So we start at the back, we dive through the process to the beginning, and we only read the points or the pixels from the raster that are needed to create the output.
Okay.
So if you put a clipper in a raster or LiDAR processing, it's essentially the same as putting a query on that source data set and say only read this section, don't read the rest of it. So it's a very fast method of reading, say, clipping a small piece out of a large raster, because we only, to the best of our ability, we only read the pixels that we're going to need. And all of the operations you do in the middle, reprojecting, tiling, what have you, we sort of work through those backwards to figure out only the pixels we need. So that's a quick way to say clipping and LiDAR and raster is fast.
Yes.
So now we have a point cloud filter, and if we skip back to our imagery here, now this is the images of the point cloud we're looking at. You notice there's all these little dots in the air. And those dots are in the air is just bad LiDAR data. There might have been a flock of birds flying over, and the laser doesn't know the difference between birds and ground.
Right.
So we have a point cloud filter here, and that's just going to say anything that's more than 75 meters tall is not a tree or on the ground.
Okay.
So the point cloud is also classified. Now, sometimes your point clouds have like a return number on them. A lot of raw ones do, and generally you can say, well, you know, last return is the height of the vegetation. First return is the ground. In this case, the LiDAR is being classified, and we're going to extract from the classified raster just the ground points and the high vegetation points. And now we're separating these two into two different streams. So we're taking that one LiDAR set, and we're taking the top points off to one stream. We're taking the bottom points off to another stream.
Okay.
So actually, the whole hand movement, it really doesn't work without a camera, but anywho. Now, from those different streams, we're going to create a raster surface using the Raster Generator, and we go in here, and we're this is just looking, whoops.
And there's the answer.
Here too soon again. Okay. I'm talking too slow. So we're just going for a general area really where there's high trees. So we're not really doing a really high resolution spacing. We're creating a fairly low resolution raster off of this each of these. Now once we've created a raster for the trees and a raster for the ground, now is where we're going to use the raster expression evaluator. And this is a little bit complicated. It's kind of math and an if statement at the same time. So we're saying if the top of the trees minus the ground is less than 2.5 meters, we're just going to set that to 0.
Yeah.
Otherwise, keep the value of the top of the tree. So we have all our vegetation heights except for where they're less than 2.5 meters, at which point we say, you don't count.
Smack that to 0, but otherwise give me the right thing. So we're going to have a D, or well, not really a DM, but an image.
It's
not an image, a numeric
height map.
Numeric raster, but it's capped at the smallest anything will be is 2.5. Exactly. Otherwise it's 0. So
in the previous raster expression evaluators we saw with the Spanish example, we were just doing math on a single raster.
Yeah.
Now in this we're taking two rasters.
Got it.
So it will do this math for each pixel.
Yeah.
In the two rasters that essentially sit on top of each other.
Yeah.
So from that output, we write the heights up to a GeoTIFF, which can handle the LiDAR, the 32-bit LiDAR data. Now we also want a classification map as well.
So this is what someone just was asking. Can we take rasters and make them into vectors? And that's exactly what this is doing.
That's exactly what we're doing. The raster cell coercer is going to say, for each pixel, make me a little square polygon around that pixel.
And then merge me, I think, with the guys that are next door that are the same.
Actually, in this case, we're not, but we have that opportunity.
Yeah.
Or we either have another, what is it? It's the raster.
Oh yes, I know what you're talking about.
So, okay, there's another one, and it escapes me right now, where you can actually, it does that merge step on.
Yes.
So you essentially give you a polygon around all the matching pixels.
Yeah. So anyway, you're making them into, so the answer to that person is, there's many ways to do this.
Yeah. So we take those output polygons, and based on their value, we map different colors.
Got it.
And we send those out to map info.
Yeah.
In this case, I've just rerouted everything to the visualizer. So here's what we see. So if we look here, there's our GeoTIFF. And if we click on a pixel, we'll see it's got the band value is 2, 2, 20, etc. And oh, there we go.
There we go.
Okay. And now here we've got our polygons. So we know that this area, you got to send the loggers out there. There. This we're good. This maybe we'll come back in a couple of years.
Okay.
Right? So that's pretty much the example there.
So a couple of examples about raster math, basically.
Yeah.
And
so the key here is the raster expression evaluator.
Right. It can do interesting math, and from that, then you can start to make interesting conclusions.
Yeah. And this is the same. Transform, I believe, that Dimitri set up that wants to do pan sharpening.
Yes, you can do pan sharpening with this thing with the right formulas in there.
Yeah.
But we should do a better job of maybe making that more obvious. We're almost running out of time, Dave. So we got, I think, one more big example. The good news, folks, is that if they're interested in this example, they can visit our website and actually see Gavin, who's on today. So thanks, Gavin, for tuning in from the UK, present this thing himself.
Yeah, I'm just going to hit some of the highlights, and possibly not the highlights he wants us to hit, but the ones that we're most interested in and to our webinar today. But I really recommend going and seeing the actual video of the presentation. It's really quite good. And actually, all of the videos from our user conference, all the presentations from our user conference are online, and you can watch them. And these, like I said, our users are actually a lot smarter than we are when it comes to using FME, and there's some really cool things being done with FME that make good examples.
And in fact, if you go to that site, you can even see all the ones, it's categorized by raster or point cloud or whatever, so you could actually see it that way.
Yeah.
So anyway, so let's just take a skim through Gavin's good work.
Yeah, so he was doing creating a rapid response flood maps. Combination of FME functionality and external tools to create flood maps. Basically, using FME where possible, but where you needed some really nitty-gritty, heavy-duty programming, he would kick it out to RSS Imagine, and we're going to just show you how those two can be integrated together. So that just shows you some of the images used. Now this is his processing workflow. So
the green boxes are FME, and the lighter green is RSS.
So there's the different steps there. So you see that download write to disk, then flood detection is done in RSS, and then more steps done in FME, and then the final pan sharpening is done in RSS, and then back to FME again. So we're bouncing back and forth a few times.
Yeah.
So that's the main workspace. It's actually controlled by FME, so you run FME, so it's fully automatable like any FME workspace.
So using FME really as a very intelligent scripting glue language that's piecing together, it's spatially aware, it's doing a bunch of things, and it's calling out a key point to RSS.
Yeah. So this is the first section where we're essentially downloading the satellite imagery off the web using in this case, the image fetcher, which is like a variation of the Raster Reader. Yeah. The difference is that the image fetcher allows authentication parameters, whereas the Raster Reader does not yet.
And an OGCW, a web coverage service, is being used as one of the sources of input as well.
Yeah, so the spatial filtering is done on the web coverage service to get the images to download. So similar to what we did in the previous example. Now this mid-translation read-write. So to pass the raster image between FME and Imagine, the simplest way at the moment is to write it to disk and then tell Imagine where it is.
So that's what those two transformers extract the image into an attribute temporarily and then smack it down to disk.
Yep.
And then bang, we call Python to go out to Imagine to do its good work.
Yeah, and so these are the two models, Imagine models being run on the data. And here's how you run them in FME using the Python caller. So you just import the Imagine module.
Yeah.
And this is actually fairly simple. You just call the module and away it goes. And I'm assuming that they used a fixed file name so that the model knows where the data is. Okay, once the Imagine has done its work, now the data is ready to be read back into FME. And we have created two data sets here. So we have two raster readers.
Yes.
They go off and read the results back into FME. So
as rasters.
As rasters. So we've dumped the results. We're bringing them back now. Okay. Now there's again this data is sent out to Imagine to do the pan sharpening.
Yeah.
And this one's a little bit more interesting. It's a little bit more complex code, but the previous Python seemed to run essentially a CAN model within the RSS, which is similar to our workspaces, right?
Yeah.
This one is actually building that model in the code itself.
Right.
So it's building up the pan sharpening model and then
dynamically building it. Yeah. So sophisticated, very, very sophisticated raster processing going.
Yeah, and this sort of shows you the results of pan sharpening here. So you have a low resolution color and it now looks prettier and sharper once it's been enhanced with the black and white image. Another way to look at pan sharpening is you're colorizing a high resolution black and white image. Okay, now this is the part where he's generating the raster output. So he's taken the pan sharpened image. There was some other processing being done converting the Imagine output of the flood mapping to vectors, polygons. And we're going back from vectors back into raster using the Mapnik rasterizer. The Mapnik rasterizer allows you to create rasters of your vector data with all sorts of symbology and stuff applied.
And we've just received a question from Greg saying, can we have a 2-hour webinar just on the Mapnik rasterizer? And you know what, we should do that. We should just have a special thing for all the Mapnik fans because it is outrageously powerful.
Yeah, and a little on the complicated side. So all these are going to Mapnik rasterizer. Now the interesting thing about the Mapnik rasterizer was it actually started out as an external module that was called the same way Imagine was when Mark Ireland was experimenting with it. And it became, was successful. We could use Mapnik within the workspaces, so then it was kind of brought in and made a full member of the FME family.
Yes.
But it started out.
And in fact, we may do the same thing eventually with Imagine as well.
Yeah. Figure
out a way to integrate it a bit more tightly so that you don't have to do this business of writing the files out and reading them back and so on.
Yeah.
So anyway.
So yeah, and if anyone has packages that they'd like to see integrated with FME, by all means drop us a line at support@safe.com and it gives us an idea where we should be working. So the output, if this is the output from the Mapnik rasterizer, so you have and this is the raster data, I mean, it's a raster image. So you've got the pan sharpened satellite photo underneath. You've got the flooded areas and the highways as rendered vectors on top.
Yeah.
That's a pretty darn good looking map.
That is. Yeah. I wonder what these little asterisks mean.
I'm guessing it's some sort of barrier.
I have to ask Gavin.
Yeah.
Gavin's online. But anyway, bottom line is all this stuff has been rendered together with a lot of different tools being integrated into one run.
Yeah. The other cool thing is he used FME's Excel writer to write the image and a whole bunch of data and charts out to Excel, and creates a very professional looking report that anyone would look at and go, wow, that's pretty cool.
Anyone with Excel, which is a lot of people.
Yeah, yeah. And that looks like, you know, a really professional looking report. And the thing is, it's all done automatically.
Right. FME produced that Excel. So the Mapnik rasterizer output was jammed in there. Some tabular data that came out of the calculations in the workflow was jammed in there. And then this graph was created on the fly by Excel because it was in the template. He even branded it so that everybody knows that it was done by Sterling Geo.
Yeah. So you can get a really nice looking report that looks like you spent hours putting it together, and boom, it's a mouse click away.
Right. And if tomorrow morning there's new satellite imagery, you click, you get this thing again.
Exactly.
Right. That's the key, the automation afterwards.
Yeah. So Dr. Dave's advice is basically FME's Python caller allows you to use outside modules if you find something that FME can't do or doesn't do to your liking. And if you have a module or if you have some other piece of software out there that can do it as a Python interface,
yeah,
go nuts.
And Dr. Dale's advice is don't be afraid to use Excel as your output format.
Yes.
Because you know, that was the surprise twist ending that I didn't see coming when Gavin first showed this to us, and I think that democratizes this in the information that was derived, and you don't need to have a heavy viewing tool of any kind. You're just in business immediately.
Yeah, the Excel writer and the PDF writer are great for that sort of thing.
I have a little private project that skunkworksy thing. If folks would find it useful to output these kinds of reports like that Excel to Microsoft Word, I know we got some European customers that have done that, but not in a very repeatable way. So I'd like to be able to write reports to Word, actually to PDF, and even a more of a tabular way like this, and maybe even HTML. Wouldn't that be crazy, Dave? Yeah. And then we could get so crazy as to do it to Google Docs someday too. Wow. So FME is kind of a way to take this spatial stuff and dump it into these reporting platforms in a automatable way. Might be fun. We're almost out of time, Dave. I think we got one more thing. This is just for fun from our friend Owen, who's growing trees with FME. And Owen was the winner of our Mapnik contest, and he's begun a blog playing with Mapnik and FME, and no two trees are the same. These are somehow generated randomly.
Yeah, it almost, if I remember my fractal days, it looks like a bifurcation fractal.
Yes. So anyway, you can read how Owen's pulling that off on his blog. And that was his award-winning map, which I think is somewhere in Scotland, which is still part of the UK.
Yes.
We were worried about that when we went because it was right on the edge. But this is a trace, I think, of delivery routes of some kind. I don't remember. Owen will have to tell us. But it was tabular data. Yeah. It was tabular data that had basically sources and destinations, and then he used FME to generate the arcs and then blend it all with a bunch of different data, and it's rocking cool. Yeah. And that appears in our beta splash screens, and so Owen is infamous now for that.
Yes.
So there we go. We have a poll just to end, and then we'll look at a couple questions. I think I'll run the poll. So just to get a sense for us to know what you found the most interesting today or the most relevant, please let us know that way. Or you can type in to us if we missed the boat and really you'd have loved to have known how we could do arbitrary convolution kernels. Which we can't do right now, but that would be something that I know Dean has been lobbying for, and I have been as well. Going back to my university days long ago, would have been fun to do that, or any other things that you might find FME to be valuable to do. So we'll stop this poll now and just take a peek. So lots of people love that no data. That's one of the things that hangs you up at first in this business of alpha versus no data value, getting that right, getting it set up right before you get into the transformers that work on things. That's a key thing to walk away with the knowledge of. But really, it looks like folks were quite interested in almost all that we did. So thanks very much looks like you found it useful. So we'll just go back to any other questions for the last minute. Before we get to that, we got some training coming up. We got to do a raster training again. We have done that in the past. I think we need to do another raster training. If you're on this webinar and you'd like a 4-hour session of raster training, say yes in your questions and answers thing, and that'll help us get motivated to finally offer that again. Did we offer one at the user conference, do you know?
Oh, I don't remember, I'm sorry.
I wonder if Dean knows. Anyway, so that's that. And we got in a webinar in a week's time on this same sort of thing, but as we did today, but talking about utilities. So I'm guessing that means power.
Yes.
And gas and stuff like that.
Sewage.
Telcos.
Yep.
Sewage is always fun. Okay. I love this raster font that we used, incidentally. It reminds me of my Atari 8-bit days. How about you? Did you do any Atari 8-bit days, Dave, or not?
Yeah, I remember Pong.
Yes.
I'm that old.
So let's just see if there's any, lots of people saying that they want the raster training. That's great to see people asking. So the presentation, somebody's asking, are we going to send this out afterwards? Yes, we will. You will get a copy of all this stuff. This recording will be made available, these slides, these hyperlinks, and all of Dr. Dave's workspaces.
Yeah, and Dr. Dave is available at support.safe.com, or actually www.safe.com/support anytime. If you have any raster problems you need solved, by all means give us or any of our support guys email, and we're always happy to help you out with a sample workspace to show you how to get you over some of the humps.
Okay, well, you know what? We are done our time, so I'm going to say that we'll wind it up here. If you've asked us questions and we didn't get back to you yet, we will afterwards, and so don't be afraid to keep asking questions. Our team will stay around. But otherwise, I'm going to just thank you so much for tuning in. It's so fun for us to present the amazing things our users do. Thanks to all those users that made their stories available for us to represent today. Thank you, Dave, for digging in and figuring them out and maybe throwing a few tips here and there. But for me, this is Dale saying goodbye.
Goodbye.